Now the question is can you hum the right tone to get that sound? Do you know the tone of the bells when they ring? Like, where are they, right? Isn't that interesting how maybe you've heard it every day over and over and over, but you just really can't sing the same note? Fun fact. All right. Here's factoring. Ready? We know how to put them together. We know how to put it together. We can expand. We've been doing that the whole last chapter. So 2x times x plus 5, really quick, what do we get? I don't have time. Let's go. 2x squared plus what? 10x. Good. Next question, what do you do with it? Let's go. Oh, my word. Okay, so just to let you know, when I'm getting that stuff open, you should be getting your book open, right? So that when I'm rolling, you're rolling, and we're all rolling down the road together. All right, don't want to be behind. So what is x plus 1 times x plus 3? Someone do it quickly for me. Go. I'll call on you if you don't.
X squared.
Thank you. X squared
Plus 4x.
plus 3x plus 1x. Let's do it that way for a second. I'm glad you got 4x out of the deal. And then plus 3, right? So Adrian just skipped one step, and he could see that there was a 4x plus 3, and he was all done. Yeah? Okay, so I don't need to go through all of this and do it all. Let's do the last one. How about this guy? Okay, Angelina can. Go, Angelina.
2x squared.
No?
What?
We're skipping that one. Do the next
Oh,
one.
the next one. Thanks. X squared
Uh-huh.
plus 25.
Oh.
Wait, mine.
Okay, I'm going to do the whole thing. I'm going to go plus 5x minus 5x and then minus 25, right? Okay, so then we end up with x squared minus 25. This is a fun one. We'll be talking about that, okay? Those are going to be called a difference of two squares. Difference means subtract two squares, and it's going to factor nicely, okay? In these examples, we have expanded a product of polynomials to form a sum or a difference. In this unit, we are concerned with the opposite process, okay? We've learned how to expand. In this chapter, we're going to break it up. We're going to look at this whole big trinomial, and we're going to break it into pieces that multiply together to get the original, and that's called factoring. I'll tell you right now, if you don't learn how to factor in 10th grade, forget going on to -2 or -1. Just don't even go there. Just next year, go to 20-3. It will be what's best, because factoring, especially in the -1 curriculum, I think I told you, kids kept a tally of how many times I said we have to factor first. It was like in the hundreds, okay? And that's only in one chapter. Like, I cannot tell you how pervasive this concept is when we get together as math teachers and we talk about what do kids need to know to be successful on their diploma. Factoring. Here it is, okay? All right, let's learn. So there are a few things we're going to do. I'm going to skip this first page, go to the next page, 322. There are a few concepts, principles that are important to every kind of factoring, no matter what you do. And that's going to be looking for the greatest common factor. So let's go back a little bit in our brains to when we learned about what the greatest common factor was. We talked about that this year in the first chapter, right? We did the factor trees. We know the difference between the greatest common factor and the lowest common multiple. Is that this grade? I think it is. Okay. All right. So you look at 48 and 72 and you think, what is the greatest common factor of 48 and 72? I know. 24? Is it 24? It's 24. How do we know that? Well, here's what you can do. You will not probably have to go through this process every time because the numbers will be easier. But you can always write out the prime factors of each number. Use your little factor tree. Do it, right? You know how to do that? And then do your 72. And then if you want to find the greatest common factor, remember it's a number that will be smaller than 48 and 72, probably. And we're going to, do you remember how to do that process? Look for the ones that are common to both. Yeah? So they each have a 2, so you write it down. They each have another 2, you write it down. They each have another 2, you write it down. Oh, that guy has 4 2s, and that guy, okay, no more 2s. We got them all. But they do each have a 3. Remember this process? And Then you times 2 by 2 by 2 by 3, and you get 8 times 3 is 24. And you find out the greatest common factor of 48 and 72 is 24. Okay, just a quick review. How about 6a cubed and 9a squared? Well, just look at the coefficients first, the 6 and the 9. What's the greatest common factor of 6 and 9? I don't need to do factor tree. I can think about it in my head. What's the greatest common thing they have? A 3. Okay, so I write down a 3. And then you look at the a cubed and the a squared. A cubed is a squared is just a. How many do they actually have in common? A, right? And then you look at the 9a squared guy, he's got a b with him, but I don't have a b on the other guy, so that's not in common, don't count him. So it turns out my greatest common factor between 6a cubed and 9a squared b is the 3a squared. That's the biggest thing that they have in common. Make sense? Any questions? All right. So I'm not going to write out the prime factorization of 8 and 20. I think we can do this. What is the greatest common factor of 8 and 20? All in favor say 4. Okay, we've got 4. You sure? We're sure. All right. So the greatest common factor of just the 8 and the 20 is a 4. All right, let's look at the x's. One term has x squared and the other term only has an x. What's the one that they have in common? Just x, plain old x. Okay, one has y squared, one has y cubed. What's the most they have in common? Y squared, you're done. Picking it up? All right. Here's this little note guy. The greatest common factor of two simple monomials can be determined by inspection by taking the greatest common factor of any numerical coefficients. Those are the numbers involved. And multiplying by each common variable to the lowest common exponent. So the greatest common factor between 10 p cubed q and 15 p squared q squared is 5 p squared q. Are you surprised by that? Okay, so let's go. In each case, state the greatest common factor. 12 and 15, what do I got? What is the greatest common factor? Look at these numbers, the coefficients first, and decide what you need for the number. 3, Mackenzie says. Are you in favor? Okay, how about AB and a squared b cubed? What's the most that they have in common? AB. Good.
Run hard, run fast. Okay.
Okay.
Yeah.
How about letter B? I got 18 and negative 24. Do you think I need to worry about the negative? No, you don't. Forget the negative. Leave them alone. Look at the 18 and the 24. What is the greatest common factor between 18 and 24? I got 2 6s. Anybody else have a different number that's better? 6 is true. Is there a higher one? No, that's it. Okay, I got 6. Okay, look at the letters. Look at your X's. What's the most that they have in common? You know? X to the third, right on. How about the Y's? What's the most they have in common? Y squared. Okay, good. Next.
Does the negative on the 20?
You don't even worry about the negative.
No?
Leave them there.
Okay.
Okay, how about on letter C? What do we got? What's the greatest? Okay, I got A, B, and C involved, right? What is the greatest A power? First of all, there is a 1 here. I am not going to put a 1 down. I'm just not going to do it, okay? You can if you want to, but you do not need to. That's unnecessary because it's assumed that everything will have a 1 in front. Okay. So I have an A. Do they have a B in common? Nope. C to the what? C to the what? 2. Yeah. Good over here. Ooh, I got a negative 40, negative 20, negative 10. What's the greatest common factor? Ignore the negatives. How much? 10. Okay, give me some letters. A to what power? 2. B to what power? B to what power? 1. Right on. Owen, good job. There you go. Is this making sense to you? Okay, so this is the first thing in all forms of factoring, Adrian. This will be the first thing you ever do. is look for common factors. It's imperative. Okay. So I'm just going to go show you how to do that. All right. When you look at 21x and 14y, we are told to factor this. That means to break it into pieces that multiply together to get back to the original. I'm going to say it one more time. Factoring is breaking apart polynomials or numbers that can be multiplied together to get back to the original. Okay? All right. So when you look at 21x and 14y, what do you think is common between the 21x and the 14y? 7. So you take a 7 and you put it in front. You basically are factoring that out and leaving yourself a bracket with the rest of it. Is it true that 7 times this stuff will get me back to the original? Okay, you have factored then. That's what it was to factor. Okay, let's go over here. When you see 5x4, 15x cubed, and 5x squared, what's the common factor? Quickly. So look at the number first. 5. Is there anything else that is common to all 3 of those terms? Isaiah, it's got to be in all 3 terms. What else is common besides the 5? Is there anything else? X squared. Okay, this is what you're going to factor out. And you're going to leave yourself a bracket, and you're going to put everything else in the bracket that you need to get back the original. So I would need to have an x squared here, so I could get back 5x4. I would need to have a plus 3x, so I could get back plus 15x cubed. You see it? I would need to have a plus 1. Notice the plus 1. That's important. So you could get back the 5x squared. Now, is this a true equal statement? Is the left side actually equal to the right side? Okay, then I have done it correctly. All right, so they're kind of helping you figure out how to do this. This is like taking your hand and helping you take the first steps, and then pretty soon they're going to let go, and hopefully you can walk. Okay? Bicycle illustration. Do you remember your parents helping you learn to ride the bike? First they hold on. Did you have training wheels? Anybody have training wheels? Training wheels. And then the day they took them off, they held on to the training wheels.
Yeah, see? And then mine was higher than the other, so I had to go one wheel. I didn't have two wheels.
Or you only have one training wheel?
One training wheel, so you're like on the one side.
Oh man. Did you live on a gravel road? How much gravel got stuck in your hands or your knees if you wiped out, right?
I did not wipe out the grass.
Exactly. You had to learn to ride on the grass?
Yeah, I did. I learned on the grass. She took Nash and I was like, I was like, taking your training wheels on and took them off. We just had to like learn to go on.
Okay, so come back now. That was a good wake you up moment. So now come back and we're going to talk about the greatest common factor. So again, they're changing the steps. They're still helping you take step by step. And they're saying, let's look at this information here. 5a squared plus 25a. Think about what's common. I got a 5 and an 8. I'm going to remove it and put it in the front of the bracket. Then inside my bracket, I have to put everything in there that I need to get back the original. So they give me an A, and they give me a plus sign. What else do I need so that when I multiply it, I get back to 25a? A 5. Say it louder. Let's get on. You got it? Does that make sense? Is my left side equal my right hand side? Okay, next. I look over here at 18p minus 16q, and I say, what's common? 2. All I got is a 2. You divide out the 2. You're actually dividing out the 2 if you think of it that way. So you're factoring out the 2. What do you have to have left inside your bracket so you get back to the original? A 9, a p, and they did the rest of it for you. Is the left side equal to the right side? Okay. All right, let's go a little bit harder. Okay? Going a little faster now. Negative 4mn minus 6m squared, what's common? Now here you have options. You can take out the negative or you cannot. You can do whatever you want. But normally we remove it so that what's left in the bracket looks nicer. It's not wrong to not do it. They're going to take out a negative 2. And then they also notice that there is an m in common. So they're dividing out a negative 2m. What do you have left in here? So when I multiply this in, I get back a negative 4mn. What do you need? Do I need a negative sign? No. Do I need a number? What is it? 2. Do I need any letters? An N. Okay, good. That one is done. Now move to the next thought. Don't write anything down. Just think a minute. What is the next number that I will need? 3. Will it need to be positive or negative? Okay, Evan, right here. So right here, I got to decide what sign to put. This is already a negative, and I'm going to be multiplying this in. So a negative times a positive gives me the negative. Are you with me? Now that is where people make a mistake. You can see why. You have to think about it. Don't just assume something. And now I will need a 3 and an M. Close your bracket. Following? Okay, this is the next one. 18x squared minus whatever, all that stuff. There's 3 terms. By the way, if you have 3 terms right here, you will have 3 terms in your bracket. Okay? All right. They noticed, they helped us, they figured out that the common factor to all 3 of those terms is a 9 and an x. You on it? So now we got to factor this, we're going to break it into pieces that multiply together. So I have my bracket to show that I'm going to be multiplying it. So I put the bracket down to say I got to multiply this. Okay, what do I need to multiply by to get back to the original statement? A 2, another x, and what else? Y squared. Perfect. Okay. Then look at your sign and you say, okay, if I have a positive 9x, I'll have to multiply it by a what to get my sign? Always look at your sign. A negative will be what I need. Okay, and then what are my numbers? So think about your sign, your number, and your letters. Okay, what's my number? A 5. Do I need an x? No, I already have it. It's in the 9x. So I just need the y. Okay, and then lots of people say, I'm done. Because I divided up the 9x. I put the 9x in the front, so I don't need one. Yeah, you do. Because if I don't put a plus 1 in there, I can't get back this guy. Don't forget the 1, okay? You have to get back to the original statement. Now, will the right side be exactly the same as the left side if I multiply it? So we did good. Okay, here we go. There are no more training wheels. It is time to go. But I will walk you through it first. So I'm running beside your bicycle right now, trying to help you do this. Okay, it says factor each polynomial. Factor means break into pieces and multiply together to get back to the original. How fast can you say that? Okay. Okay, and we're going to remove the greatest common factor. That's the first thing we're always going to do, no matter what kind of factoring. Even when you're in grade 12, I'm going to be saying, did you forget? And they're like, oh, I didn't remove the common factor. And I'm like, yes. Okay? All right, here we go. What's common? Just a 2? All right? But that is not equivalent. So I must put a bracket here. And I must write an equivalent statement to the what about it. What will I need to put in there? 10x plus 3 or minus 3? Minus 3. Done. Move on. What's equivalent? What's common factor in part B? Isaiah, what's common? 4. Anything else? X squared. That is not equivalent yet. I have to write an equivalent statement. So what else do I need? 4. X squared. That is not the same. I have not written something that's equal to what I had before. Plus what? Excellent work. C. Logan, what's common? I should wait a second. I'm going to cut it back. Okay, just write it down here. All right. Letter C, Logan, you're on.
2.
Okay. Keep going.
A.
Just an A?
Yeah, just an A.
Okay.
And B squared.
Excellent work. And what do I have left, Adrian?
5A squared.
5a squared
Plus 4B.
plus 4. I just need the b. And then what?
Plus B squared.
Plus just the b squared. Is he right? I think so. Is that an equivalent expression to what I had to start with? Okay, always ask yourself. I have said that so many times right now. I'm trying to help you. I am modeling the thinking process. Okay? So I'm thinking, okay, am I done? Is what I have now the same as what I had before? Okay, let's skip D. Let's go to E. It looks hard. Hannah,
Yes.
what's common?
5.
Okay? What else?
X
Uh-huh.
and y squared
Yes.
and z squared.
Z squared. Can you please make sure your Z does not look like 2? On one of your tests, someone was confused between, you wrote this down. No, it didn't look like that. It was more like that. And it was a V, not a 6. Okay? You got sloppy. I can't even do it. It was like, yeah, kind of like that. And you didn't decide if it was a B or a 6. Okay, it was a B. I couldn't decide if it was a 6. So be a little bit careful, okay? You gotta be neat and tidy. Melissa's work is exceptionally neat and tidy. You should check out her work. Okay, what else we got here? That's the common thing. Write small and write neat. Okay, if I remove that factor from all of the terms, how many terms am I going to have in this set of brackets? 3. Because I have 3 terms to start with, I will have 3 terms that I'm down inside the bracket. You with me? What will I have? 5?
Z.
Just a Z?
Yeah.
It's not a 52. Make it a Z. Okay, what else do I have? Minus 4 x y squared. And then plus 6x what? Cubed? I'm good on the y. I need a z to the 3. Okay, good. Is it making sense to you? Okay. Let's go down. I have one more little example. So just when you think you got it, they throw a little cone in there. Do you like cones? Oh. If they're full of ice cream, they're good. Quick question, do you choose the plain old cone or do you choose the waffle cone?
Waffles.
The waffle cone, but then they dip it in chocolate. So there's chocolate on the top.
Of the waffle cone.
Yeah.
I can't tell you how long it's been since I had an ice cream cone, let alone the waffle cone, let alone dipped in chocolate.
Why?
Oh man. Okay, here we go.
Really?
We have ice cream.
I have like
So my ice cream and my eating of ice cream entails about one bite. I'm like, can I have a bite of your ice cream cone? Have a bite of my husband's ice cream cone. That's all I get. It's great. Okay. He's pretty good. He's generous. He comes and he says, "Do you want a bite?" I'm like, "Yes, please. Can I have a bite?" Okay. The surface area of a cone is given by the formula A equals pi r squared plus pi rs. You would not need to know that. They're going to give you the surface area of a cone. By the way, if you open that cone up, what do you think it looks like? It ain't a circle. It's kind of part of a circle. You don't understand how hard it is for kids to make a cone. You remember making the cone on your Tin Man hat? It's not as easy as you thought. I give you a piece of paper, I say make a cone. And then kids start doing this, and they come to me and they say, is this good enough? I'm like, no, that is not good enough. That isn't a cone. That's I don't know, right? I mean, it's just harder to make a cone than you think it is what I'm trying to say. And then they go like this, and then you have this, and then, right? It's just harder than you think. Okay. Anyway, it's not even half a circle. So it's this weird, it kind of is circular in some parts. That's why there's a pi r squared. But then there's a pi r s thing. Okay. Where r is the radius of the base of the cone and s is the slant height. Do you know why there's a pi r squared in it? The base. Yeah. This is a circle right here. That's a perfect circle, right? If you actually make a good cone, that's a perfect circle, and the area of every circle is pi r squared. Then the rest of it, the pi r s, is because it's this kind of curved-looking shape. Okay. It says determine the surface area of the cone to the nearest 0.01, that's hundredth of a squared centimeter, if it has a slant height of 7.4 and a base radius of 2.6. We can do this. So you take your A, you put in your pi, your radius squared is 2.6, we're going to have to square it. Then plus pi times the radius times the slant height, which is 7.40. You know what I'm saying? So go ahead and your calculator and tell me what you get. We're supposed to do this the nearest 100th centimeter. Okay, do we have an answer yet? So there's 100th of a centimeter, squared centimeter, sorry. Area equals what? Okay, say it louder, Angelina.
81.60.
0.68
Yeah.
meters 100 centimeters squared. Okay, good. That was not hard. You did not need to know anything about factoring to do that. That was just plug into a formula, punch in your calculator correctly, and you're trusting that Angelina did it right. Right? Did anybody confirm that number? Okay, good. Then it says write the formula for A in factored form. Oh, mercy. All right. There it is. Now we gotta write that in factored form. To factor it means to break it into pieces that multiply together to get back the original. So, are there any common pieces in those two terms? Pi and r. So let's remove the common factor. And when I do that, I'm going to multiply it by something else to get back the original. What would I have to multiply it by? R plus s. There it is. In factored form. So now what you could do is you could just add the r and the s together. That's what we've just learned. Instead of having something funky like all of this stuff, add your r and your s together. Here's your radius and your slant. What do you get? 7, 8, 9, 10. Dare I say 10? Okay, I got 10 in here. Then I'm going to times that by the radius, which is 2.6. Oh, isn't that 26? And then I'm going to times it by 3.14. So really my answer is 3.14 times 26. Much less work than typing in pi r squared plus pi rs plus, right? What is 3.14 times 26? Imagine that. 81.68. So as far as typing in my calculator and doing things a little bit in my head, the factored form was way easier, much less room for mistakes. On the calculator, you can get your brackets wrong, you can put the squared wrong. So anyway, now you know. Okay, let's do some work. Any questions about that? Why I would do that? What was the point of that? I don't know. Just trying to tell you that sometimes factoring it helps make it simpler.